Yes, tie wraps or cable clamps are acceptable for securing Type NM cable, provided specific conditions are met. Near the box, within 8 inches or 12 inches, the cable must be secured with a staple or another approved method. Along the wall, spacing is key. The tie wraps or cable clamps must be spaced no more than 3 feet 6 inches apart. Ensure the tie wraps or cable clamps securely bundle the wires, preventing separation or sagging. Caddy cable clamp devices are also suitable for securing Type NN cable, offering multiple clamps to hold several wires. Proper installation and secure clamping within the device are crucial. These methods offer benefits including faster installation. Tie wraps and cable clamps often install more quickly than individual staples. Cost reduction is another advantage, as you'll only need one staple near the box and tie wraps or cable clamps for the remaining spacing. Improved wire management is achieved by bundling the wires, keeping them organized and preventing tangling. Remember, always adhere to the guidelines and requirements outlined in the National Electrical Code, NEC, when installing electrical wiring. If uncertainties arise, consulting a licensed electrician is always recommended. Let's delve deeper into the NEC requirements for securing non-metallic sheath cable, commonly known as Type NM cable. The NEC provides specific guidelines to ensure safe and reliable electrical installations. According to the NEC, Type NM cable must be supported and secured to the building structure in a manner that protects it from physical damage. This support must be provided at intervals not exceeding 4.5 feet and within 12 inches of boxes, cabinets, fittings, and other cable terminations. These requirements are found in NEC Article 334.30. The purpose of these requirements is to prevent the cable from sagging, kinking, or becoming damaged, which could lead to electrical hazards. Proper support and securing also help to maintain the integrity of the wiring system and prevent future problems. When using staples to secure Type NM cable, they must be installed in a manner that does not damage the cable. The staple should be positioned so that they straddle the cable without compressing or cutting into the outer jacket. It is also important to use the correct size staple for the cable being installed. Using staples that are too small may not provide adequate support, while staples that are too large can damage the cable. Tie wraps, also known as cable ties, are another acceptable method for securing Type NM cable. When using tie wraps, it is important to select a product that is listed and labeled for the intended application. The tie wrap should be made of a durable material that is resistant to UV radiation and other environmental factors. They should also be installed in a manner that does not damage the cable. The tie wraps should be tightened securely, but not so tightly that they compress or cut into the outer jacket. Cable clamps are another option for securing Type NM cable. These devices typically consist of a metal or plastic clamp that is attached to the building structure. The cable is then inserted into the clamp and secured in place. When using cable clamps, it is important to select a product that is listed and labeled for the intended application. The clamp should be sized appropriately for the cable being installed and should be installed in a manner that provides adequate support. In addition to the general requirements for supporting and securing Type NM cable, the NEC also includes specific requirements for certain types of installations. For example, when Type NM cable is installed in accessible attics or crawl spaces, it must be protected by guard strips if it is run along the floor or within 7 feet of the floor. This requirement is intended to prevent the cable from being damaged by foot traffic or stored items. Similarly, when Type NN cable is installed in unfinished basements, it must be run along the floor joists or protected by guard strips. The NEC also includes requirements for the installation of Type NM cable in damp or wet locations. In these locations, the cable must be installed in a raceway or otherwise protected from moisture. It is also important to use fittings and connectors that are listed for use in damp or wet locations. When installing electrical wiring, it is important to follow all applicable codes and standards. The NEC is the primary source of information for electrical safety in the United States. However, state and local codes may also apply. It is important to consult with a qualified electrician or electrical inspector to ensure that your installation complies with all applicable requirements. Now let's consider the practical implications of these NEC guidelines in real-world scenarios. Imagine running Type NM cable along a wall in a residential dwelling. The first step is to determine the appropriate spacing between supports. According to the NEC, supports must be provided at intervals not exceeding 4.5 feet. This means that you will need to install a staple tie wrap or cable clamp at least every 4.5 feet along the length of the cable. In addition to the spacing requirement, the NEC also requires that supports be provided within 12 inches of boxes, cabinets, fittings, and other cable terminations. This means that you will need to install a support within 12 inches of each electrical box, switch, receptacle, or other device that is connected to the cable. When selecting the appropriate method for securing Type NM cable, there are several factors to consider. Staples are a common and inexpensive option, but they can be difficult to install in tight spaces. Tie wraps are more versatile and can be used in a wider range of applications, but they may not provide as much support as staples or cable clamps. Cable clamps are the most secure option, but they can also be the most expensive. Ultimately, the best method for securing Type NM cable will depend on the specific circumstances of the installation. It is important to consider the cost, ease of installation, and level of support provided by each option before making a decision. Another important consideration is the type of building structure to which the cable will be attached. If the cable is being run along a wooden stud or joist, staples or tie wraps can be easily attached using nails or screws. However, if the cable is being run along a concrete or masonry wall, cable clamps may be the better option. Cable clamps can be attached to concrete or masonry using anchors or adhesive. When installing Type NM cable, it is also important to avoid damaging the cable. The outer jacket of the cable provides insulation and protection against electrical shock. If the jacket is damaged, the cable may become a safety hazard. To avoid damaging the cable, use care when installing staples, tie wraps, or cable clamps. Do not over-tighten the fasteners, and be sure to position them so that they do not compress or cut into the jacket. In addition to the physical support and securing of Type NM cable, it is also important to protect the cable from physical damage. This can be accomplished by running the cable through a raceway or conduit. A raceway is an enclosed channel that is designed to protect electrical wires and cables. There are many different types of raceways available, including metal conduit, plastic conduit, and flexible metal conduit. The type of raceway that is used will depend on the specific application. In some cases, it may not be necessary to run Type NM cable through a raceway. However, if the cable is exposed to physical damage, such as in a garage or workshop, it is a good idea to provide additional protection. Another way to protect Type NM cable from physical damage is to install it in a location where it is not likely to be disturbed. For example, the cable can be run along the top of a wall or ceiling where it is out of reach. It is also important to avoid running the cable through areas where it is likely to be exposed to moisture or chemicals. In these areas, the cable should be installed in a raceway or otherwise protected from the environment. Finally, it is important to remember that electrical work can be dangerous. If you are not comfortable working with electricity, it is best to hire a qualified electrician. An electrician will have the knowledge and the experience to install electrical wiring safely and in accordance with all applicable codes and standards. They can also help you to select the appropriate materials and methods for your specific installation. Let's consider some specific examples of how these principles apply in various scenarios. In a new residential construction, before the drywall is installed, the electrician will run Type NM cable throughout the house to provide power to outlets, switches, and lighting fixtures. They will typically use staples to secure the cable to the wooden studs and joists, ensuring that the spacing requirements are met. They will also install supports within 12 inches of each electrical box. In a renovation project where existing walls are being opened up, the electrician may need to reroute or extend existing wiring. In this case, they may use a combination of staples, tie wraps, and cable clamps to secure the cable, depending on the specific circumstances. They will also need to ensure that the new wiring is properly spliced and connected to the existing wiring. In a commercial building, the requirements for securing Type NM cable may be more stringent. This is because commercial buildings typically have more complex electrical systems and are subject to more stringent inspections. In these buildings, it may be necessary to run Type NM cable through a raceway or conduit to provide additional protection. It is also important to use fittings and connectors that are listed for use in commercial applications. In addition to the NEC requirements for securing Type NM cable, there may also be local codes or regulations that apply. It is important to check with your local building department to determine if there are any additional requirements that you need to follow. By following these guidelines, you can ensure that your electrical wiring is safe, reliable, and in compliance with all applicable codes and standards. Remember, if you are unsure about any aspect of the installation, it is always best to consult with a qualified electrician. They can provide you with expert advice and guidance to help you complete your project safely and successfully. One crucial aspect to consider is the ampacity of the Type NM cable being used. Ampacity refers to the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacity of different types of conductors, including Type NM cable, based on their size and insulation type. When selecting Type NM cable for a particular application, it is essential to choose a size that is adequate to carry the expected load. If the cable is undersized, it could overheat and potentially cause a fire. The NEC also specifies requirements for adhering the ampacity of conductors in certain situations. For example, if multiple conductors are bundled together in a conduit or cable tray, their ampacity must be adhered to account for the increased heat generated by the proximity of the conductors. Adhering factors are specified in the NEC and must be applied carefully to ensure that the conductors are not overloaded. Another important consideration is the voltage drop in the wiring system. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends that voltage drop in branch circuits should not exceed 3% and voltage drop in feeders should not exceed 5%. To minimize voltage drop, it is important to use conductors that are large enough to carry the load and to keep the length of the wiring runs as short as possible. The NEC also includes requirements for grounding and bonding electrical systems. Grounding is the process of connecting the electrical system to the earth, which provides a path for fault current to flow back to the source. Bonding is the process of connecting all of the metal parts of the electrical system together, which creates a low impedance path for fault current. Proper grounding and bonding are essential for preventing electrical shock and fire hazards. The NEC specifies the types of grounding and bonding conductors that must be used and the methods for installing them. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. In addition to the technical requirements for electrical installations, the NEC also includes requirements for labeling and identification. All electrical equipment must be clearly labeled with its voltage, amperage, and other important information. This information is essential for troubleshooting and maintenance purposes. The NEC also requires that conductors be identified by color coding. For example, the neutral conductor must be white or gray, and the equipment grounding conductor must be green or bare. Color coding helps to prevent accidental miswiring, which could lead to electrical hazards. The NEC is a comprehensive and complex document that covers all aspects of electrical installations. It is essential for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements carefully. The NEC is updated every 3 years to reflect the latest advances in electrical technology and to address new safety concerns. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and compliant. Let's delve into some of the specific NEC articles that are most relevant to securing Type NM cable. Article 334, as previously mentioned, covers non-metallic sheath cable, types NM, NMC, and NMS. This article outlines the permitted uses and restrictions for these types of cables, as well as the requirements for installation. Section 334.30 specifically addresses securing and supporting Type NM cable. It details the spacing requirements, the methods for securing the cable, and the requirements for protecting the cable from physical damage. Article 300 Wiring Methods provides general requirements for all wiring methods, including Type NM cable. This article covers topics such as protection against physical damage, protection against corrosion, and the proper use of fittings and connectors. Article 310 Conductors for general wiring covers the requirements for conductors used in electrical wiring systems. This article includes information on ampacity, voltage drop, and conductor identification. Article 250 Grounding and bonding covers the requirements for grounding and bonding electrical systems. This article is essential for ensuring electrical safety and preventing electrical shock and fire hazards. Article 400 Flexible cords and cables covers the requirements for flexible cords and cables, which are often used for connecting portable appliances and equipment. While Type NM cable is not a flexible cord or cable, this article provides useful information on the proper use of flexible wiring. It's worth noting that the NEC is not intended to be a design manual. It is a safety standard that provides minimum requirements for electrical installations. It is the responsibility of the designer and installer to ensure that the electrical system is properly designed and installed to meet the specific needs of the application. In addition to the NEC, there may also be other applicable codes and standards that must be followed. For example, the International Building Code, IC, contains requirements for electrical systems in buildings. The IBC references the NEC and other standards, and it may include additional requirements that are not covered in the NEC. It is important to check with your local building department to determine which codes and standards apply to your project. To summarize, securing Type NM cable is a critical aspect of electrical installations. By following the requirements of the NEC and other applicable codes and standards, you can ensure that your electrical wiring is safe, reliable, and compliant. Remember to use appropriate securing methods, maintain proper spacing, protect the cable from physical damage, and consult with a qualified electrician if you have any questions or concerns.